Welcome back to another video. This is Dr. Tarcia Huber here, and in this video we are going to continue to talk about truth tables. So if you watched the last video, we talked about truth tables for negations, conjunctions, and disjunctions, and in this video we're going to talk about truth tables for the conditional and the biconditional. Alright, so starting with the conditional. Remember, a conditional is an if-then statement. So let's assume that I told you, if you do the work for the course, then you will pass the course, okay? So if you do the work, then you will pass the course. All right. So my P is you do the work. And my Q is you pass the course. So we want to consider all the different possible scenarios of what could happen here. Alrighty. So again, I'm going to start my truth table with my P's and my Q's. So remember, P is true, true, false, false. Remember, when you set up a truth table that has two statements, then you set up P with true, true, false, false, and you set up Q with true, false, true, false. All right, so we want to think about each situation. All right, so this is a promise that I made to you, and basically this statement is true as long as I keep my promise. The moment I don't keep my promise is the moment this statement will be false, the if-then statement. So this statement, the if-then statement, P implies Q, will be false whenever I don't keep my promise. So let's say you do the work, P is true, and you pass the course, Q is true. If that's the case, then I kept my promise, you did the work, and you passed the course. So that if-then statement was actually true, okay? Now in this next case, say that P is true, meaning you did the work, but you failed the course, okay? In this case, if you do the work and you fail and you still fail the course, then in that case, I did not keep my promise. My promise was you do the work, you pass the course. But you did your part, you did the work, and you didn't pass the course. So in this case, the if-then statement would be true, would be false, okay? Now the next case is if you don't do the work, but you pass the course. Alrighty. Now, my promise was that if you do the work, you'll pass the course. Now, I didn't say anything about what happens if you don't do the work, okay? Now, if I would have said something about what happens when you don't do the work, then that would be a different promise. But in the promise I gave you, I never said anything about what would happen if you didn't do the work. So in this case, if you don't do the work and you still pass the course, I still kept my promise. I did not let you down, okay? So the if-then statement would be true. All right. Now in the last case scenario, if P is false, you didn't do the work, and Q is false, meaning you didn't pass the course, then again, I kept my promise. I did not let you down. And so the if-then statement would be true. Alrighty. So I kept my promise, and this would be the situations for the if-then statement. Okay. And I wanted to use an example to help you understand why the if-then statement is true in all these cases except that one case where I didn't keep my promise, okay? So the if-then statement, the conditional statement, is always true except in the case when the first statement is true and the second statement is false. If the first statement is true and the second statement is false, then the if-then is false. Other than that, all other cases, the if-then statement is true. All right, let's look at an example. For this first example, we want to construct a truth table for not Q implies not P. Now remember that arrow, which can be read as implies, is an if-then statement. So this says if not Q, then not P. So we want to construct a truth table for this statement, and we're going to start with our simple statements, which are P and Q. And it's just habit of putting P first. There's nothing that stops you from putting Q first, so you actually could do that, but just out of just habit, we normally put P first. So P is true, true, false, false. So you always start off when you have two statements, true, true, false, false, and true, false, true, false. And this will give you every possible combination of how P and Q can be true and false. All right. So also I noticed that in my statement I have a not Q and a not P. And since the not Q is first, I'm going to do the not Q first. And remember, that's the negation of Q, which just means you change all the signs of the Q. So Q is true here, you make it false. Q is false here, you make it true. It's true here, you make it false. And it's false here, you make it true. Okay. And then the not P is next, so I'll do that one next. And not P, negation of P is the opposite of P. So P is true, true, false, false. So the negation of it would be false, false, true, true. All right, so then my next column would be the not Q implies not P, or the if then. So remember, the conditional is always true except in the case where the first statement is true and the second statement is false. So what I'm going to look for is that case, the case where the first one is true and the second one is false, which is here. So that statement would be false. And you could have more than one of those cases, but the other statement, the first one is true, the second one is true. So this is actually the only case in this one where the first one is true and the second one is false. So that means all of my other ones would be true. And so that would be the truth table for not Q implies not P, or if not Q, then not P. Okay. Okay, we're going to do another truth table. In this example, example 2, we're going to construct a truth table for P or Q and not P implies Q. All right. So now we have, it's 2 simple statements, but there are multiple compound statements in here that we have to go through and break it down piece by piece. Now, since there's 2 simple statements, we'll start with the P and the Q. And again, P is true, true, false, false. And Q is true, false, true, false. So we'll always start with that whenever there are 2 simple statements. And then the next thing I would do is, so I'm just going to go in order. I would do the P or Q next. So P or Q, remember with the or statement, the disjunction is true when at least one of them is true. So this one would be true, this one would be true, this one would be true, and this one would be false. All right. Then I'm going to do not P next because I have to combine P or Q and not P with and. So I need to know what is not P. Well, not P is the opposite of P. So that would be false, false, true, and true. Alrighty. So now I have these 2 that need to be combined with the and. So my next part is going to be P or Q and not P. So I'm looking at this column and I'm looking at this column and I'm combining them with the and, the conjunction. So now remember, the conjunction is true when both statements are true. Well, in this case, they are not both true, but here they are both true. And that's the only case where they're both true. So that means all the other ones would be false. Okay, and then for the last part, I'm going to do this whole statement, this P or Q, which I'm going to have to squeeze it in here because I'm about to run out of space. P or Q and not P implies Q. So this is the if then statement, and I'm using this column, and my second column is the Q column. Okay, so this, if this, then this. So remember, that statement is false. The if then statement is false when the first one is true, which this is the only case with the first one true, and the second one is false. Well, in this case, that does not happen. So that means there are no cases where, in this one, where it is false. That means all of these would be true. All 4 of them would be true. Now, whenever every value comes out to be true, that is called a tautology. Tautology, okay? Now on the flip side of that, whenever every statement comes out to be false, that is called a self-contradiction. Okay, so a tautology is when every statement comes out to be true, like in this case, and self-contradiction is when every statement turns out to be false. Okay, now we're going to talk about the truth table for the biconditional. So remember, the biconditional is if and only if. Now, I mentioned in a previous video that if and only if is the same thing as saying, so if and only if P. So if we have P, if and only if Q. All right, that's the same thing as saying if P then Q and if Q then P. So it's basically, it goes both ways. The if then goes both ways. So it's if P then Q and also if Q then P. All right. That's what the biconditional is equal to, right? So in order for us to determine what the truth table for the biconditional is, we need to look at the truth table for this. So basically, I'm going to group these 2 and I'm going to group these 2 and I'm going to change that and to the conjunction symbol. So I need to look at the truth table for this, and this will let me know what the truth table for the biconditional is. So let's create a truth table for this. So I'm going to start off with P and Q. Again, you just start off with your standard true, true, false, false. And then true, false, true, false. And so for the first one, I need to know what is P implies Q, or if P then Q. And remember, that's false when the first one is true and the second one is false, which is here. And that is the only case where that happens, so the rest of these would be true. And now I will want to figure out what is Q implies P, because I need to combine these two together with the and. So Q implies P. So I'm looking at this column first and this one second. So remember that it's false when the first one is true and the second one is false. Well, this first one is true, the second one is true, so that wouldn't be false. Here, the first one is true, the second one is false, so that one would actually be false. That third case right there will be false. That means all of the other ones would be true. All right. And so now I want to combine these two, the if P then Q and the if Q then P, with the and. So for my last column, it will look like this. P implies Q and Q implies P. So remember, the and is true when both statements are true. So in this case, they're both true, so that will be true. Here, they are not both true, so that will be false. Here, they are not both true, so that will be false. And here, they are both true, so that will be true. So now, this gives me the biconditional. So now, if I look at my original situation, notice that the biconditional is true when they are both true, and the biconditional is also true when they are both false. So we can conclude that the biconditional is true when the original two statements have the same truth value. Okay, so either when they're both true or when they're both false, that's when the biconditional is true. All right, so now let's look at some examples of creating some truth tables with the biconditional. In this example, we want to construct a truth table for P or Q, if and only if not Q. If not Q, then P. Okay, so that is, we have a disjunction, we have a biconditional, and we have a conditional. So we have three different compound statements in here, and we need to break it down and do this piece by piece. We notice that we only have two simple statements, so we will start with the P and the Q. And I'm going to start all the way over here because this is going to be a long truth table. So I start with P and Q, and remember my statements that I start with: true, true, false, false, and true, false, true, false. So those would be the first two that I start with. And I'm just going to go across because I'm just going to start with these parentheses right here, the P or Q. Those are grouped together, and I'm just going to move from left to right. So P or Q, that's the disjunction. Remember, the disjunction is true when at least one of them is true. So this would be true. This would be true. This would be true. And this would be false. Okay. So that's the first one. And then I need to combine these two with the biconditional. So I need to figure out what this is next. Well, notice in here I have a not Q. So I need to figure out what is not Q before I can figure out what that conditional is. So not Q is the opposite of Q, which is false, true, false, true. All right, that's the not Q. And next I will figure out what is the not Q implies P. So that's the conditional. So that means I'm looking at this column first, the not Q column, and then the P column second. Now remember, the conditional is false when the first one is true and the second one is false. So the first one is true here, the second one is not false, so that one wouldn't be false. But here the first one is true and the second one is false, so that would be the case where it's false. All the other cases would be true. So we will put true in the other three cases. All right. And now for the last part, we can actually combine these two. So I'm looking at the P or Q. If and only if the not Q implies P. Okay. So this statement first, so we're looking at this one first, and this statement second. So we're looking at this one second. Now remember, the biconditional is true when both statements are the same, or they're both the same here, so that would be true. They are both the same here, that would be true. They are both the same here, that would be true. And they are both the same here, that will also be true. So here we go again, a case where all of the values come out to be true. So this will also be a tautology. Tautology. All right. Any questions? If you have any questions, don't hesitate to email me. Put them in the comments. I'll respond when I see it. All right. If there are no questions, I have one more example I want to work. Okay. For example 4, we're going to take this statement and we're going to do 3 things to it. So the first thing we're going to do is we're going to write it in symbols. The second thing we're going to do is we are going to construct a truth table for it. And the third thing that we're going to do is we are going to give an example of a situation where this will be a false statement. Okay. So here's the statement. If you do a little bit each day, then you will get by. And if you do not do a little bit each day, then you will not get by. Alrighty. So there are actually 2 simple statements in there. There's P and there's Q. So P is do a little bit each day. And Q is actually you will get by. Those are the 2 simple statements in there. All right. Those are my statements. And now I want to take those for the first part and I want to put them in symbols. So the first part is the if then. If you do a little bit each day, then you will get by. So that's P implies Q. And notice there's a comma there. So that means we're going to group those together. And then there's the word and. So we're going to put the and sign right there. And then the next part is if you do not do a little bit each day, so that's not P, then you will not get by. So that's another if then statement. You will not get by is not Q. So this will be that statement in symbolic form. And now we want to construct the truth table for it. So for part B, we're going to construct the truth table for it. We're going to start with P and Q because those are our simple statements. That's true, true, false, false. And that's true, false, true, false. So we always start like that. And then the first statement we have here is P implies Q. And remember with the conditional, that's the conditional. It's false when the first statement is true and the second statement is false. So it's false here when the first one is true and the second one is false. So I like to identify the false case first and then just write the rest of them true. But that's the only case where the first one is true and the second one is false. So now I need to combine this with this. So that means I need to know what is this first. So in there's a not P. So I need to figure out what not P is. And there's also a not Q. And I actually supposed to be figuring out these headings first. I'm not being consistent with how I was doing it in the last video. But you can figure out the headings first or you can just go along as I've been doing it. It's best to figure out the headings first though. So not P would be false. That's an F. False, false, true, true. And not Q would be false, true, false, true. Remember, these are the opposite. These are the opposites of the Q. All right. So now I want to do not P implies not Q. So this is a conditional. Remember, the conditional is false when the first one is true and the second one is false, which is this case right here. That's the only case where that happens. The first one is true and the second one is false. So that would be false. All of the other statements would be true. Okay. And then for the last column, I'm going to have to squeeze it in here because I'm running out of room, is the whole thing. P implies Q and not P implies not Q. Alrighty. Now we're combining these 2 statements with the word and. So here's the first statement. Here's the second statement. And we're combining those with the and. So remember, the and is true when they're both true. So they're both true here. That will be true. They are not both true here. That will be false. They are not both true here. That will be false. And they are both true here. So that would be true. And so that's how you would construct the truth table for P implies Q and not P implies not Q. Now the last part is we want to give a scenario of where this statement is false, or when this statement is false. So I just come to my final truth table, the truth table of the compound statement, and I look for a case where it's false. So there are actually 2 cases where it's false, so you can use either one of those cases. I'm just going to go with the first one. The first one is the case where P is true and Q is false. And so that's all you have to write for that one. That is the situation, or that's an example of a situation where you get a false statement on that example. Okay? So I know it's a lot, but you have to take it and break it down piece by piece, okay? And then you have to remember when the values are true or false for each type of statement. So when the values are true for the disjunction, when at least one of them is true. When are the values true for the conjunction? When they're both true. When are the values true for the conditional? In all cases except when the first statement is true and the second one is false. And then when are the values true for the biconditional? That's when both values have the same truth value. Okay, when both statements have the same truth value. If you have any questions whatsoever, please don't hesitate to ask them. And you can email me. Again, I will reply. I want to keep saying that because I don't want y'all to think, oh, I'm an emailer and she's not going to reply. I will reply. So send me an email or write a comment on the video. And I will see you in the next video. Thanks for watching.